Welcome to our first experiment. Today we will learn about aggregate impact value. So at first we should know what is aggregate impact value. Aggregate impact value gives a relative measure of resistance of an aggregate to a certain shock or impact. Okay, this is the very important thing. That means aggregate impact value actually provides a relative resistance to a sudden shock, and I think you know what is sudden shock. The example of a sudden shock is, say, if you hit a cricket ball with a bat, that is the impact load, because the magnitude of the load is too high comparatively to the contact time. So that is called impact load. Or if you hit anything with the hammer, that is the impact load. And definitely the performance of an aggregate will vary from a slowly applied load to an impact load. So with aggregate impact value higher than 30, the result may be anomalous. That means if the AIV value is higher than 30, actually we won't accept the material. And there is a limitation of the size, that is size larger than 40 mm are not appropriate to the aggregate impact test. The standard aggregate impact test shall be made on aggregate passing a 40 mm BS standard test strip. BS standard test strip means British standard, and definitely written on 10 mm. That means the aggregate will pass through 40 mm but will written on 10 mm. So that's important. Then we will know about the apparatus. Actually I will show you a video, then I will describe about the apparatus. Next point is the preparation of the test sample. So first point, you have to take aggregate passing through the 40 mm VS standard strip and written on the 10 mm base standard strip. Then the aggregate shall be tested in a surface dry condition. So for that we need to keep the aggregate in an oven at around 110 degrees Celsius, and the time period is 4 hours. Okay, that's very important. And then the samples shall be cooled to room temperature before testing. Now we will learn about the testing machine. The total weight of the machine is 45 to 30 kg. The machine has a metal base, a cylindrical steel cup, and the inner dimension is 102 mm and depth is 50 mm. A metal hammer of 13.5 to 14 km, which can slide from to 380 plus minus 5 mm height. The aggregate should pass through the 14 mm shape but written on the 10 mm. And later we will use 2.36 mm. I will explain that later. Just first remember that the aggregate should pass through the 14 mm shape but written on the 10 mm BS shape. Tamping rod, a balance and an oven is needed in the experiment. And what I have told you earlier, the sample must be passing through the 14 mm tip and written on the 10 mm tip. And the sample must be dried for the 4 hours at 110 degrees Celsius to make it dry. Cylindrical measures are filled in 3 layers and each layer same 25 times. Once filled, the surface is leveled. Then we will take the weight of the aggregate. Let W1 be the weight of the aggregate. Actually this is the initial weight. Then we place the machine in a plain ground so that it can take the impact load and it don't move. Then the cup is placed at the base, and then we will keep the aggregates in 3 layers with 25 tamping. And definitely we will provide 25 strokes per layer. Then we will release the hammer from 380 mm height and it will provide the impact load. And we will let fall the hammer freely. 15 blows. After 15 blows, the crushed aggregate is removed from the base. Then we will place the aggregate on the 2.3 mm strip. And then we'll take the passing amount. And the fraction passing through the 2.36 mm strip is weighted. That is W2. So now I will show you a real example. So this is our real machine, what you have seen in the animated one. This is 40 mm BS standard strip, and this is 10 mm BS standard strip. This is 10 mm. and this is 2.36 millimeter sieve, and this is our weight meter. At first we will take samples. Definitely we should take sample randomly. After that, we will place the sample on 40 millimeter sieve. Then we will shake that manually in circular motion. And we will take the materials passing through the sieve. We won't take the materials that will retain on the sieve. Actually, we will take the materials that passes through the 40 millimeter sieve. Then we will place the materials on 10 millimeter. We will take the materials that retain on the sieve, not passing on the sieve. We won't take this. Actually, we will take the materials that retain on 10 millimeter sieve. So that's how we select our materials. Then we will keep the materials in oven for 4 hours at 110 degrees Celsius to make it completely surface dry. Let the material cool down. Then we will make the cylinder weight as 0. Then we will fill that in 3 layers, and each layer we will provide 25 stroke. When it will be filled, then we will make it level. Then we will take the weight. Let the weight be 357.7 gram. So this is our initial weight, 357.7 gram. This is weight of oven dried sample. Then we will place this in the base plate. Again, we will provide 25 strokes. After that, we will keep the screw very tight so that it don't move during the impact loads. Then we will release our hammers and we'll let it fall freely for 15 times. After 15 blows, we will stop. Then we will untie the screw. Pass the materials through 2.36 millimeter sieve. as there is dust, that's why we will use a cover. This is our cover. Then we will shake manually in circular motion. After shaking, we will take the weight. This mattress is passing through 2.36 millimeter, and we found the weight is 25.3 gram, and the aggregate impact value is the ratio of weight of fraction passing 2.36 millimeter divided by weight of overhead sample. So that is 25.3 divided by 357.7 gram. So after calculating, we got 7.07%. So that is our aggregate impact value. I have attached a data sheet with the lecture material. Fulfill the data sheet and write down the sample calculation here, write down the result here, and then submit it with your report.